Number 1 asks us to find the unit vector in the direction of the given vector. Write our answer in the indicated form. So here's our vector right here. We want to find the unit vector, and so there's a formula for that. Okay, and so to find the unit vector, we need to do 1 over the magnitude of the vector they gave us times the original vector. Okay, and in this case they named our vector u, so I named my vector u as well. The magnitude of our vector is basically like the Pythagorean theorem on the 2 points they give us. So if the first number is a and the second number is b, we would plug it into this formula and say that the magnitude of u, which that's what the absolute value bars means, is the magnitude of our vector, equals the square root of 1 squared plus negative 5 squared. So we work that out and we get that that is square root of 26, which you cannot simplify. So our magnitude is square root of 26, so if we plug into this formula, we're going to have 1 over the square root of 26 times what our original vector is, which is 1 comma negative 5. So we distribute into our vector that 1 over 26. So that's going to give us 1 over the square root of 26, comma, negative 5 over the square root of 26. And then it actually asks us to write this as a linear combination of the standard vectors I and j, which means instead of being in component form like it is right now, they want us to do 1 over the square root of 26. We put an I next to it, we put an I next to our x value, and then it would be minus, since it's a negative for our second answer, minus 5 over the square root of 26 j. Or if you wanted to rationalize, it'd be square root of 26 over 26i minus 5 square roots of 26 over 26j. Whichever one of those and that you want to get. Angle between two vectors has a formula. We would say that theta equals the inverse cosine of the dot product of u and v over the magnitude of u times the magnitude of v. Okay, so on top here, because these are two vectors, this is the dot product. On the bottom, that's just multiplication. Okay, so that means we have to find 3 things really before we even plug into this formula. Dot product and then the magnitude of each of these. The dot product, if you remember, here's another formula. You do, like if we label these x1, y1, x2, and y2, we would be multiplying our x's together, multiplying our y's together, and then adding the 2 together. So in this particular case, we would do negative 4 times 6 plus negative 8 times 1, which gives us negative 32. And then we would go to our magnitude. So in the last problem, we already talked about how to find the magnitude. So this would be square root of negative 4 squared plus negative 8 squared, which is square root of 80 on the bottom, not on the bottom, magnitude of v. So what I'm trying to say, 6 squared plus 1 squared, which is square root of 37. Don't bother simplifying this because we're about to plug it into a formula and then plug it into our calculator. So there's really no point in doing it. So just leave it alone. Theta equals the inverse cosine of negative 32 was the dot product over the square root of 80 times the square root of 37. So there's probably a lot of different ways you can plug this into the calculator, but make sure you do it in a way that is correct. On the bottom, it might be helpful to have an extra set of parentheses around the square roots to make sure they get done in the correct order. If you type this incorrectly, and also if you realize it asks us to make this be in degree mode, so change it to degree mode if you haven't already, we would get 126.0 degrees, rounded to the nearest tenth. Find the product or quotient as indicated. Leave your answer in trigonometric form. So, in case we don't remember, this is an imaginary number that's in, or a complex number that's in trig form because it has the angles in it, and it actually also, each of these really basically has a parentheses and a 1 in front. Sorry that's kind of hard to read on that, but normally we have a number out in front and that's in parentheses, but in this case, since there's not a number there, then there's a 1 there. So let's talk about formulas. Okay, first off, what we're talking about is Z1 is our first complex number, and in general it has R1 times cosine of theta 1 plus I sine theta 1. So this is like our first complex number, so it has 1s for its variables. Our second complex number would be R2, and then would have cosine of theta 2 plus I sine of theta 2. So this is what they're starting off giving us. If we want to divide the complex numbers, which is, they told us find the quotient, so we're dividing, then here's what our formula looks like. It has R1 over R2, and in parentheses we have cosine, and since it's division, we subtract our angles. The formula for multiplying is really similar. We multiply our r's together whenever that happens, and we add the angles together, we don't subtract it. So let me fix that. And also notice that we subtract the first angle, or we do the first angle minus the second angle, so order matters, don't forget. So Z1 over Z2 equals, our r's are both 1, and in parentheses here we have our angles subtracted. So our first angle is pi over 2, our second one is pi over 6. And so what we need to figure out really quickly, kind of as like a side note, is what is pi over 2 minus pi over 6. If you're really bad at fractions, you could, on your calculator, do 1/2 minus 1/6, and it would tell you what that is. And, I mean, that's one way of going. Common denominator here would be 6, so we would multiply the first one by 3 on the top and the bottom, so 3 pi minus pi gives us 2 pi over 6, which is really just pi over 3. And then we would go ahead and say, well, 1 over 1 is 1, so we really just have cosine pi over 3 plus I sine pi over 3. Since it says leave in trigonometric form, that's our answer. Find the unit vector again. So this time they gave it to us with i's and j's. They want it in component form, go figure. So I'm actually going to start off by switching this to component form. Hey, look, now it's in component form, 3, 5. And so the unit vector formula we said was 1 over the magnitude of u times the vector u. So that means we need to find the magnitude of u. So that's the square root of 3 squared plus 5 squared. 3 squared is 9, 5 squared is 25, so that's the square root of 34. So 1 1 over the square root of 34. We multiply by our vector. So that is 3 over the square root of 34, comma 5 over the square root of 34. Or if you rationalize that, that would be 3 square roots of 34 over 34, comma 5 square roots of 34 over 34. Whichever. Here we go with De Moivre's theorem, or if you prefer, De Moivre's theorem, to find the indicated power of the complex number. And we're supposed to write our answer in standard form, a plus bi. So here is, where is it? Here is De Moivre's theorem, our formula for it. If we are trying to find z to the n, first off, we have to have our number be in trigonometric form, which would look like this. And so what we're saying is, hey, raise that trig number to the n power, and so that equals r to the n times cosine n theta plus I sine n theta. Okay, so the n is the power. So the first problem we have here is this is not in trigonometric form. So we need to get it into trig form. And so what we need to do is figure out what r would be and what theta would be. To find r, we basically do the Pythagorean theorem on these two numbers. It's negative square root of 3 and what's in front of I, a 1. So if you do that, oh, that's a squared there. That's important. Try that again. Alright, if you do that, you get square root of, no, you get regular 3 plus 1, which is 4. Square root of 4 is 2. So r in our trig number here is 2. Now we need to find theta, so we do that by looking at the location of this number, negative square root of 3 plus I. Negative square root of 3 is like our x value. The 1 in front of I tells us our y value, so that's a triangle that's over in the second quadrant that has, this is not drawn to scale, an x value of negative square root of 3, y value of 1 means that its hypotenuse is 2. This is a special right triangle. The angle to get around there, well, the one on the inside here is pi over 6. So to get around to there, it'd be 5 pi over 6. So that's our theta. So this would be cosine of pi over 6 plus I sine pi over 6. This is all being raised to the 6th power. So now we're ready to plug into the formula. So 2 to the 6th cosine 6 times pi over 6.
Okay, bye.
Plus I, and then we would have sine times 6 times pi over 6. And then we have to basically simplify that. What is 2 to the 6th? 2 to the 6th is 64. Cosine of 6 times pi over 6 should give us, that should be 5 pi over 6, shouldn't it? Not pi over 6. So 6 times 5 pi over 6 is 5 pi. So cosine 5 pi plus I sine 5 pi. It asks us to put this in standard form, a plus bi. So what that means is we need to actually figure out what cosine of 5 pi is, and then distribute the 64. So 0 is over here, pi is over here. If we keep going around, that means 2 pi is here, 3 pi is here, 4 pi is here. So 5 pi is over here. And at 5 pi on the unit circle is the point -1, 0. So that means cosine of 5 pi is -1 and sine of 5 pi is 0. Well, I times 0 is 0. If I distribute the 64, that means my answer is simply -64. Find the indicated roots, write the answer in trigonometric form. So these are always fun. We have this formula that if what they give us is in trigonometric form and they ask us for the nth root, and so because they're asking us for the nth root, then n in my formula is going to be whatever root it was. In this case it's 4th root, so that'd be 4. But anyway, here's the formula. The nth root of r times cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. And the k in this formula starts at 0 and is going to keep going until we get to a number 1 less than n. So if n is 4, like in this case, then we'll plug in k as 0, 1, 2, and 3, because those are all less than 4. All the numbers from 0 up until you get to 4, but not including 4. So, also, note that 2 pi is the same thing as 360. So the formula kind of depends on, did they give us an angle in radian or degrees? So this is in degrees, if you notice. So we would really want to use 360 instead of 2 pi. So in our formula, they told us it's the 4th root, so that means n equals 4. The number in front, which is 81, that's r. And then the angle is 320. So we need to plug all this in. So the 4th root of 81 times cosine of our angle plus 360k over 4. I'm going to leave k in it for right now, and then we'll plug in k here in a second, plus I sine 320 for theta plus 360k over 4. And then since it's the 4th root, that means that we're going to have k equals 0, 1, 2, and 3. And then notice there are 4 numbers here, and it's the 4th root. That's what should happen. You shouldn't end up with 5 numbers if it's the 4th root. So the 4th root of 81, that's 3. Because it's in degrees, there's not really anything else we can do to simplify. So we're just gonna go for it and start plugging in k's. So starting with k equals 0, we would get, so that's not divided by 3, because that seems confusing. This is 3. So 3 times cosine of 320 degrees plus 360 degrees times 0 over 4 plus I sine 320 degrees plus 360 times 0 over 4. Well, if it's times 0, then that goes away and that goes away. So we really just need to know what 320 divided by 4 is. And it would be 80. And since they asked us to leave this in trig form, or to write it in trig form, then this would be our first root, just like that. So now we need to keep plugging in numbers. K equals 1. So now what I need to do is on top 320 plus 360 and then divide by 4. If I do that, I get 170. And we just keep going. $320 plus 360 times 2 divided by 4 gives you 260 degrees. And last, k equals 3. That should give us 350 for the angle. Draw a graph of the rose curve. They give us this equation. So the 4 in front means that the petal length is 4. It's telling us the petal length, that number in front. Cosine is telling us that we have x-axis symmetry, although we could actually have symmetry around the x-axis, y-axis, and the origin, depending on what's going on. Since it's an even number in front of theta, there are double that many petals. If you wanted to just plug this into the calculator, make sure you go to mode and change it to polar, and also make sure that you're in radians. And then it might be helpful to zoom to a standard window, depending on where your window is, depending on what the last thing you've graphed is, and what this looks like. Is since there are twice as many petals as 2, that's 4 petals. So there's a petal right here, there's a petal right here, there's a petal right here, there's a petal right here. Then you stop, admire your work, and say, oh, look at the pretty flower. Well, this one turned out kind of blurry. Sorry about that, but it shouldn't be blurry on your paper. So look at your paper. The graph of a limicon or limicon curve is given. Without using your graphing calculator, determine which equation is correct for the graph. So you're going to have your calculator to use on the whole test, so let's pretend like that's not there. Make sure you're in radian mode and you're in polar mode, and type each one of these in, and the only one that looks like it has a loop is C. So that's your answer.